I hope you're well wherever you are. Today I want us to go through this question. It's also from the topic the mole in Form 3, 20.0 centimeters cubed of a solution containing 4 grams per liter of sodium hydroxide was neutralized by 8.0 centimeters cubed of dilute sulfuric 6 acid. Calculate the concentration of sulfuric 6 acid in moles per liter. Into bracket we have the relative atomic masses of the different elements. For sodium it's 23.0, for oxygen 16.0, while for hydrogen it's 1.0. So I hope by now you can easily predict the very first step that we shall have. And the first step is that we are going to write a well-balanced chemical equation. So let us begin together. So write a well-balanced chemical equation. And just to remind you, a well-balanced chemical equation, 1, it should have the correct chemical symbols. 2, it should be well balanced. 3, it should have the correct state symbols. And of course, once you balance it, you should clearly confirm whether it is well balanced. So we begin. From our question, we have 2 substances that are reacting. One of them is sodium hydroxide and the second one is sulfuric 6 acid. The question also has given us a clue that it is a neutralization reaction. A neutralization reaction is that reaction where an acid and a base reacts, and the products are always salt and water. So let us begin. So this is a base, and being a base that is from a group 1 metal, it is an alkali, and so it is soluble, and so the state symbol is aqueous. Then we have the acid, sulfuric 6. Acids are also in the aqueous state, so this is the acid. The products usually takes the metal and the radical here, so giving us sodium sulfate, also in the aqueous state, then plus water. So then we begin the balancing. As I shown you last time, the balancing is all about making each and every element on each side well balanced, or have an equal number on either side, the reactant side and the product side. So from where we have the tail of the arrow, this side, we say that this is the reactant side, and from the head of the arrow, that side, that is the product side. So each and every element should be having an equal number on both sides. And as usual, again, we go following the different elements as they have been arranged in the equation. So we begin with sodium. So we check how many sodium elements are on the reactant sides, from this side all the way to where we have the tail of the arrow. So sodium is just 1. On the product side, sodiums are 2. These 2 belongs to sodium only. Sulfur do not have any number. This 4 is for oxygen. So sodiums are 2. And this side we have 1. So we multiply by 2, and this is the 2 that we shall put at the back there, so that we have 2 sodium, and we put a tick, meaning they are balanced. From there we go to oxygen. We write oxygen. We again check how many oxygens are on the reactant side. Here we have 2. You see these 2 here, it's for all the elements. So oxygen are 2 here, because here we do not have any number. Then plus these 4, so oxygens are 6. On the product side, we also check to see how many oxygens they are. So we have these 4. So we have 4 oxygens here, and then here we have 1. Last time I said that if you find an element that looks stubborn in the balancing, you leave it first. So we put like that. Here we have 5. These are 4 plus 1, and then you put a star on both sides. Now that it has not been balanced, you first of all move to the next. So next you have hydrogen. Hydrogen, we have these 2 that we said is for all. So here we have 2 hydrogens, and here we have 2. So in total hydrogens are 4. We go to the product side. Hydrogens are just 2. So we have 4 on one side and 2 on the other side. So we can easily balance this one by multiplying by 2, and the number that you multiply with is the one that you put up here. So in total we have 4. Sorry, not 2, but 4. So it is also balanced. So you put a tick on both sides. Now we are remaining with oxygen. In our previous equation I said the elements that appears stubborn in its balancing, or the element that looks difficult in its balancing, once you put a star on it, by the time you are balancing the rest of the elements, you should then check again to see if that very element has been balanced in the process. So even before we move further, let's just check to see if our oxygen is already balanced after we have balanced the hydrogen. So let's go back to oxygen. 2, these are 2 plus these 4, giving us a total of 6. The other side we have 4, and by the time you are balancing hydrogen, we have ended up with 2 oxygens, because these 2 is for hydrogen only, but this 2 is for all of them. So here we have 2 oxygen plus these 4. So now our oxygen here, they have become 6, and so they are now balanced. They are now balanced. So you can even rub the 5 that was there before. So now our oxygens have been balanced. So we are still remaining with one more, which is sulfur. Sulfur is just 1. Sulfur is just 1. Let me rub this line for you to see that for real sulfur is 1. So that is the formula of sulfuric 6, and sulfur is just 1. Why are we saying that it is 1? It's because these 2 belongs to hydrogen only, where this 4 is for oxygen alone. So sulfur do not have any number, so meaning sulfur is just 1. So we indicate that our sulfur is 1. On the other side, the same happens, that these 2 belongs to sodium, this 4 belongs to oxygen, and so sulfur is again 1. So we write sulfur 1, and then we say that sulfur is already balanced. So from our book 2, our KLB book 2, in the very many steps that are involved where we are balancing chemical equations, there is one that is very important. At the end, it says that we should check again to see whether by balancing some of the elements, if we have ended up unbalancing the others, so we can confirm. On the reactant side, we have 2 sodium. On the product side, we have 2 sodium. On the reactant side, we have 2 oxygen plus 4, 6. Then here we have 4 plus 2, 6. Then we have 2 hydrogens here, plus 2, 4. The other side we have 2 times 2, 4. Sulfur is 1, and the other side the sulfur is 1. So we have completed our step number 1, that we have just written a well-balanced chemical equation. Let's now go to step number 2. Step number 2 that comes after we balance the chemical equation, we have the interpretation of the question. To interpret the question, we are required to reread the question, and to each and every value that has been provided in the question, we write it below each and every substance respectively. So we begin. 20.0 centimeters cubed of a solution containing 4 grams per liter of sodium hydroxide. So up there we have 20 centimeters cubed, and it also has 4 grams per liter. Was neutralized by 8.0 centimeters cubed of dilute sulfuric 6 acid. So dilute sulfuric 6 acid has 8.0, which is the volume. From there we are told calculate the concentration of sulfuric 6 acid in moles per liter. And moles per liter is the other way of being told that you are required to calculate molarity, because molarity means number of moles in a liter of a solution. So after the interpretation, we can now begin the calculation, and this is where we will begin. So I hope you are very ready with your calculator, with your notebook, and I hope you have already written the question. So to begin with, step number 3, we are going to determine the RFM, which is the relative formula mass of sodium hydroxide. We determine the RFM of sodium hydroxide. To determine the RFM, the relative formula mass, we take the elements that make sodium hydroxide in its formula, and in each of them we get the RAM, the relative atomic mass, and those have been given into bracket here. So for each and every element we write the RAM and then we add all of them together. So the RAM of sodium is 23, the RAM of oxygen is 16, and the RAM of hydrogen is 1. In total we get 40. So that was our step number 3. From there we go to step number 4. In step 4, from the information that you have been provided with here, we can begin by using the gram per liter. And the gram per liter, and having got the RFM, we are now able to calculate the molarity of sodium hydroxide. So step 4, calculate the molarity. Those are the moles per liter of sodium hydroxide. And there we use this formula that molarity is equals to gram per liter all over RFM. The gram per liter is 4, so we write 4 there, divided by the RFM, which is 40, and then we get 0.1 molarity, written with a capital M. Once we do that, we go back to where we have sodium hydroxide, and just somewhere we have a new value, which is 0.1 molarity. And remembering what I said last time in our previous video, each and every value that we use in the calculation, we are supposed to put a tick to it. So meaning, going forward, this value will not be used again. That's why we have put a tick to it, to this one, 4 grams per liter. So next, we should have a step where we will use this value now and this other one. And again, we tick them once we are through with them. Step 5. We now go to the calculation of the number of moles of sodium hydroxide. And to calculate the number of moles, we will use these two values, this one and this one. So calculate the number of moles of sodium hydroxide. And I have just said that these are the two values that we use. So I always advise students to avoid cramming formulas on this one when you are using molarity and volume in the calculation of the number of moles. Instead, you interpret. For example, 0.1 capital M. That means that we have 0.1 moles in a liter. The interpretation of 0.1 molarity, capital M, it means 0.1 moles in a liter. And a liter in this case, now that you are using volume in centimeters cubed, a liter has 1,000 centimeters cubed. So we write 0.1 moles are in a liter, which is 1,000 centimeters cubed. So we then ask ourselves, then how many moles are in the volume up here, which is 20 centimeters cubed. I remember advising you to avoid in the calculation writing it as it was given up here, 20 with a 0.0. Avoid the 0.0, because who knows, maybe you will omit the point and use it as 200, which will be very wrong. So avoid the 0.0 unless it was 0.5 or 0.1. There you must use the decimal point. But if it was a 0.0, a 0.0 and a whole number as it is one and the same thing. So we then cross multiply. So 0.1 multiplied by 20 all over 1,000. Then you use your calculator, and there you'll get 0.002 moles. And it will be very necessary for you to write there the number of moles of which substance. They are the number of moles of sodium hydroxide. Sodium hydroxide. So remember, we said each and every value that you use, you make sure that you tick it. Right now, we have just got the newest number, 0.002 moles. Again for sodium hydroxide. So you write them there and very clearly. 0.002 moles. We are still on the side of sodium hydroxide. So those are the number of moles that we will use in the next step, step 6. So I hope you can still see as you continue following step by step. So on to our step number 6. We determine the ratio by mole of sodium hydroxide is to sulfuric 6 acid. We determine the ratio by mole of sodium hydroxide is to sulfuric 6 acid. To determine the number, the ratio by mole, we look at this number on the left hand side of the substance. So for sodium hydroxide, we have 2. So we write a 2 down there. For sulfuric 6 acid, there is no number on the left hand side of it. So meaning that we only have one sulfuric 6 acid, so ratio 1. And then from there we say ratio 2 of sodium hydroxide has this number of moles, 0.002 moles, contains 0.002 moles. What about ratio 1? It contains how many number of moles? So we cross multiply. So we get 1 times 0.002 all over 2. These two up here. So by 1 by 2, 0.001. So we get 0.001 mole of, we must write it belongs to sulfuric 6 acid. So that is the ratio by mole. So for sulfuric 6 acid, we have 0.001 moles. So again, just before we move on, we have already used this value. As usual, we go about ticking the values that we have already used. This one is not yet used, and down here we have just got a new value, and it belongs to sulfuric 6 acid. So these are the two values that will take us to whatever the question was all about, calculating the concentration of sulfuric 6 acid in moles per liter, which I said moles per liter also refers to molarity. So we now go to step 7. In step 7, we can now calculate what we have been told to calculate in the question, calculating the concentration of sulfuric 6 acid. So we now go to the real question. We calculate the concentration of sulfuric 6 acid in mole per liter, which is the same as molarity, denoted as capital M. And I have just said earlier on, these are the two values that we shall use. How do you use it? So we take the number of moles, 0.001 moles. You say they are in this volume. And again, avoid the 0.0 because the 0.0, 8.0 and 8, it just means that it is a whole number. So there will be no difference. So we use it without the 0.0. Because when you are doing these calculations, you need accuracy. And who knows, maybe if you use it as 8.0, you might omit the 0.0, the decimal point, when you are entering the values into the calculator, and you end up using it as 80. So to be on the safer side, use it as 8. So 0.001 moles are in 8 centimeters cubed. So then how many moles are in a liter, which is 1,000 centimeters cubed? So again, you cross multiply. Cross multiplying, you get 0.001 multiplied by 1,000 divided by 8. Once you enter that into your calculator, you end up with 0.125 moles per liter, or you can use capital M, because as I said, moles per liter also means molarity. And when you're writing the capital M, it should be with corners. So make sure that the corners can be seen. So let me write it once more with clear corners. Because if you write it like this, even when it is that big, it will be very wrong. So you use capital capital M with corners. Just note this. For molarity, even when the M is too small or this big, as long as it has corners up here, it will still be a capital M. But if you use it with rounded tops, even when it is that big, it will not be a capital M. So the kind of an M that you use here must have a sharp corners at the top. So make sure that that one can be seen for you to get it as a correct answer. So just in case you have any other calculation that you might want us to do together, you have all the freedom to leave it in the comment section. So may we continue revising for the exams that are ahead of us, those that shall come in the future. So I'm praying that you continue working hard as hard work pays. Thank you. Remember to touch the subscription button. Remember to share, to like, to comment. Let me know how you're taking chemistry. Chemistry is life. It is always very easy. You just need to have a change of attitude. God bless you.